numericals based on ionization constant of base, that is the Kb. There are some numericals we will see step by step, we will understand. 0.02 molarity solution of ammonium hydroxide 3%, and this is dissociated, and calculate the dissociation constant of ammonium hydroxide. So this is the ammonium hydroxide. So this will give you what? NH4 plus and OH minus. So initially at zero condition this will be C, this will be 0 and 0, and at equilibrium what will happen? This will give you C into alpha, C into alpha, this is C into 1 minus alpha. So we get Kb equal to concentration of ammonia and concentration OH minus divided by concentration of NH4OH. So this is nothing but the C alpha into C alpha divided by C into 1 minus alpha, or finally C alpha square 1 minus alpha. So what is alpha? So if you see here, so alpha is equal to 3% dissociated, so 3 upon 100. So this is nothing but the 0.03. So it is again less than 5. So we can put alpha. This alpha can be neglected. So again we can write directly Kb is equal to C alpha square. So we can write here C is given how much? So C is given here 0.02. So 0.02, and alpha is given here 0.03. So 0.03 whole square. So on solving you will get here answer 1.8 into 10 to the power minus 5. So this is our answer. The pH of the 0.05 molarity aqueous solution if of diethylamine is 12. Calculates its Kb. So from here we have to find out OH concentration. So pH plus POH equal to 14, or we can say POH is equal to 14 minus 12, that is 2. So concentration of OH is how much? 10 to the power minus 2. So we can write C2H5. So this is diethylamine plus water. So it is giving what? So it will give you C2H5 whole twice NH2, so plus and OH minus. So at equilibrium condition directly I am writing. So this, suppose this is X, this is X, so this will be your 0.05 minus X. So actually this is, if you see here, 0.05 minus 0.01. So this is actually 0.01. So this is nothing but the 0.01. So from here we are taking. So Kb will be how much? So Kb will be x square divided by 0.05 minus X, which is nothing but we can write 0.01 whole square divided by 0.04, because this is coming here how much? 0.04. So if you solve it, so on solving you will get 2.5 into 10 to the power minus 3. So this is the actually answer. So 0.16 gram of hydrazine are dissolved in water and total volume made up to 500 ml. Calculate the percentage of hydrogen that has reacted with water and in this solution, and Kb is again given. So write the equation first. This is the N2H4, it is reacting with the water, so it is giving you N2H5 plus OH minus. So at equilibrium what happens? This is the C, this will be your 0 0. So not at T equal to 0. So at T equal to equilibrium, so this will be your C into alpha, C into alpha, C into 1 minus alpha. So we can calculate Kb equal to C alpha square 1 minus alpha, since alpha is very small, or we can say C into alpha square almost equal to. So now concentration of N2H4, that is hydrazine, that is C is equal to 0.16 divided by 32. So this is the molar mass 32 hydrazine, and multiplied by 1000 by 500. So you will get answer 0.01 molarity. So again alpha is equal to square root Kb by C. So what is Kb? So Kb is given here 4 into 10 power minus 6 divided by concentration is equal to 0.01. So if you solve it, this will be your 2 into 10 power minus 2, or it is 2%. So this is our answer. An aqueous solution contains 10% ammonia by mass and has a density of 0.99 gram per centimeter cube. So calculate the hydroxyl H+ sign in this solution. Kl for ammonia is given this much. So we have to find the 10%. So what is the meaning of 10%? The 10% means 10 gram in 100 gram of solution. This is the mass of the solution given and weight of the ammonia is also given 10 grams. So what is the molar mass of ammonia? So we can find the molar mass of ammonia is 10 upon 17 into 1000 and 100 and divided by density. So density is also given here 0.99. If you solve it, this will come around 5.82. So we know that this is the molarity of ammonia. So this ammonia again dissolved with the water. So this will give you ammonium hydroxide. So again ammonium hydroxide, it will dissociate into ion, that is NH4 plus OH minor. So at T equal to 0, so this will be C, this will be 0, 0. At T equal to equilibrium, so this will be your C into alpha, C into alpha, this C into 1 minus alpha. So what is the OH? So OH will be how much? OH will be Kb into C. This is the actual formula that we have seen it, or we can add Kb meant is Kw by Ka into C. So we can solve. This will be your 10 power minus 14 divided by K is given 5 into 10 power minus 10 is the Ka value. So again multiplied by 5.82. So 5 point this value. So on solving, so you will get here 1.07 into 10 to the power minus 2 molarity. So this is our answer. So what is the H plus ion we have to find? So what is the H plus ion? H plus ion will be 10 to the power minus 14 divided by 1.07 into 10 to the power minus 2. So this will be 0.9268 into 10 to the power minus 12 molarity. So this is our H plus ion and this is our OH mass. So this is our answer. Of dissociation of water is 1.8 into 10 to the power minus 9 at 300 Kelvin. So what is the self-ionization constant for water? So this is given self-ionization constant water. So how we solve it? So this is the H2O plus H2O. We know the auto product less water, so it will give you H3O plus and OH minus. So at T equal equilibrium, what will happen? So this will give you C into 1 minus alpha. This will be C into alpha, C into alpha. So what is the concentration of H3 will be all equal to how much? So this will be equal to OH minus, this OH minus will be equal to 10 to the power minus 7. So C is equal to concentration of H plus into alpha. So this is equal to 10 power minus 7 divided by 1.8 into 10 power minus 9, that is 55.6. Now self-ionization constant is self-ionization constant. So K equal to this we require, that is nothing but the concentration of H3O plus into OH minus divided by H2O whole square. So we know the concentration of H2O. This is nothing but the concentration of, we can say, H2O. So this is initial concentration. So we can write here. So this is given here 10 to the power minus 14 and divided by C. So this is the C. C value we find out. This much is there, not this much. So we just find out C is given here this much. So this is the concentration of this much. 10 power minus 7 is the concentration of H plus and this is the concentration of C. So this will be equal to 55.6 of water. Water we find out. So on solving you will get here 3.23 into 10 to the power minus 18. So this is our answer.